Good day, everyone. My name is Gerald Mamasalanang. I am from the IT 31, and today I will be presenting the database enrollment system that I created, and also I'm going to be providing the SQL statements that I've used for this system. We're going to continue to the SQL statements that I've actually used for this system. So let's begin with the data definition language statements, or the DDL. So these statements defines the structure of our database, including all the tables and relationships between them. So our database, like I said earlier, consists of 10 core tables. So each designed to handle a specific entity within the enrollment system. So we start by the departments. So we start with the department tables. So as you can see here, we have the department tables. Let's go up. So here are the SQL queries that I've actually used. So we're gonna start to the department tables. So which stores the department information such as the department code and the name. So we also have the department ID here. Next is the programs table, which defines each academic programs under the department. So we have the program ID, program code, program name, and also the department ID as the foreign key. Next up is we have the student table, which keeps all the students' information such as their ID number, their name, gender, birth date, year level, and programs. As you can see, that's all the field that we've used for the student table. So for the next is the instructor table, follows containing instruction details and their assigned departments. So yeah, we also have courses table, which includes all courses codes, title, units, and lecture, and laboratory hours. So that's all that you can see. So that's all the fields that I've used for the course table. Now to manage the prerequisites, we have the course prerequisite table, which connects a course to its prerequisite subjects. As you can see there, we use course ID and the prerequisite ID to do that. Next is the room table. Defines classroom information such as buildings, room code, and capacity. As you can see there. Now next is we have the terms table, where we records semester or term details, including the start and the end dates. So you can see the term ID, term code, and the start and the end date. Next is the section table, links courses, terms, and instructions, and rooms, including the schedule, pattern time, and the maximum capacity. So finally, we have the enrollment table, which keeps track of which student is enrolled in which sections, along with the status of the grade. So we use this table to track those enrollments that we have using the enrollment ID, student ID, section ID, date of enrollment or date enrolled, status, and the letter grade for the grade of the student. So all of these tables are created using the create table statement, which with our proper data types and constraints to ensure the data accuracy and integrity. So we're gonna go ahead and proceed to the alter table statements. So after defining all tables, we're gonna go and move to alter table statements. So these are used to add primary keys and foreign keys constraints, which establish relationship between tables. So we're just gonna do, since there's a lot of here. We're just gonna do a quick examples of what we have here. So one of the examples here is the table courses. So the table course table reference the table departments table through the department ID. Next is the table students table reference the table programs using the program ID. And then the TBL enrollments table connects students and sections together with each other. So this setups ensures that the referential integrity is maintained, and then meaning every records is linked properly without duplication or found data. So we're going to go ahead to the crucial part which is the data manipulation language or the DML statements. So let's now move on to the DML language statements. So this statements handles the actual data within our database, including this select, insert, update, and delete commands. So yeah, we're gonna go ahead and proceed to the first statement, which is the select. So the select are used. So yeah, again, these select statements are usually used to retrieve and display data. They include different query variation from simple searches to complex joins. So for example, um, the department query retrieves all the departments, allowing the keyword search by their code names. And then the programs query joins the programs and department tables to show which department each programs belongs to. So for the students, for the student um, we joined the programs table to display their programs names along their personal data and their personal data. So yeah, for the instructors, we join the instructor and the department tables. And then um, for the section and enrollment, we use the multiple left joins to retrieve the combined data from the multiple tables. So we also include the search functionality using the like operation, which allows partial matches in bars. Additionally, there are drop-down queries which retrieve list of departments, programs, courses, terms, instructor, and rooms for form selection. So that's all of this multiple joins. So you also finally we have the health check queries. So let me just yeah. So yeah, finally we have the health check queries, which count the numbers of records per table, useful for monitoring the database health and the populations. So yeah, we're gonna do again a quick run through for the select statements that we used. So the departments we use the query to retrieve all the departments, allowing the keywords to be their code names, and the programs again the tables to shows which department each programs belongs to. So for the students, we actually joined like I said earlier, we joined the student programs tables to display their program names along with their personal data. For the instructors, like I said earlier, we joined the instructor with their department tables. So yeah, all sections, all courses, department names joined. Um, was used. We used multiple left joins to retrieve combined data from the tables. Yes. So yeah, we're gonna proceed to the next, which is the insert statements. So next is the insert statements. These are used to add new records to each tables, such as adding new departments, programs, students, course, or enrollment. So yeah, each statement uses parameterize the values like colon C, colon N, or colon ID to ensure the security and flexibility during the database transaction. So this helps prevents SQL injections, attacks, and keeps the data consistent. Okay, so we're gonna go ahead and next, after the insert statements that I've used, these are all the update statements that we use. So we're gonna go ahead and go to this. So the update statements allow us to modify the existing records. For example, this updating the department name, or this for the program, this is editing the student details or changing the this. We're gonna go ahead, yeah, like this, changing the enrollment status or the grade. So that's one of the examples that we've used for the update statements. So like the insert queries, this also use parameterized variables to ensure the safe and secure updates. So next is the delete statements. And finally, we have here the delete statement. The delete statement are used to remove records from the database, whatever its department, course, or student enrollment. So these are carefully controlled to ensure that no dependent data is deleted accidentally, thanks to our foreign key constraint. So these are the examples of the delete queries that we've used throughout the systems. Next, these are the summary. In total, of our system uses over 100 SQL statements categorized as follows. So first is the create table. So we have 10 statements that we've used for the create tables. Now for the alter table, we use 20 plus statements, including the primary keys, foreign keys, and the constraints. For the select, we have 25 plus statements that I've used with various joins and where clauses. Now for the insert, I've used approximately of 10 statements, one for each main table. Now for the update, I've actually used 9 statements for this, and lastly for the delete, I've actually used 10 statements for this. So this demonstrate the completeness and robustness of the SQL layer of my enrollment system. Okay, so the key features demonstrated from this presentation. So through this documentation, we've actually showcased the following features. So first is the normalized database with 10 related tables. Second is referential integrity using the foreign key constraints. Third is efficient data retrieval through joint queries. Fourth is secure CRUD operation using the parameterized queries. Fifth is comprehensive data management from students to instructor, courses, and enrollments. And lastly, search and reporting capabilities through select and count queries. So overall, this designs ensure that our enrollment system is both secure and scalable, capable of handling real-world academic data efficiency. So yeah, in summary, this documentation actually provides a complete structured SQL foundation for our enrollment system. So it demonstrates not only our understanding of database design and query optimization, but also our commitment to security, scalability, and real-world usability. So yeah, thanks for listening. This concludes the presentation for the enrollment system that I created, and also the SQL statement documentation that I presented. And again, my name is Gerald from the IT31. Thanks everyone for watching, and I hope you have a great day. Goodbye.